Hello, everyone. Welcome to another episode of One Team TV. I'm Con Kakanis, Director at One Team IT. And today our discussion is around AI and in particular on IBM Power Systems. So I'm very pleased to have welcome two guests today. But Adam Makaruga from IBM and David Cole from One Team IT. Gentlemen, welcome.
Thank you.
And perhaps, Adam, maybe we could start with you introducing yourself and your background and your role at IBM. Thanks.
Yeah, thanks, Con. So I'm a data scientist, the lead data scientist out of the IBM client engineering team. And I've been with IBM for over 6 years now. I started in their research department in Melbourne. So I was doing research on AI, mostly in the financial services sector. And then spent 2.5 years working with the systems team on power systems and everything AI on IBM Power Systems. And then more recently moved into that IBM client engineering team, where I work directly with customers to build them AI solutions using our technology, including power systems, but our software stack as well.
Fantastic. I'm looking forward to your insights today. And David, your introduction, please.
Yeah, I've been with One Team IT now for 20-something years. My focus has always been with enterprise and government clients in, I guess, the high-end IBM server and storage infrastructure. Also doing a lot of work these days with educational institutes, research institutes around high-performance computing and AI workloads.
Thanks, David. So thanks for your time today, gentlemen. So for the benefit of the audience, AI is one of those terms that I think the definition is in the eyes of the beholder. So perhaps, Adam, we might start with yourself. At a high level, how would you summarise AI from the context of today's discussion?
Yeah, I think you're absolutely right. AI gets used for a lot of things. But AI is the field of artificial intelligence, creating machines that can learn on data. But largely what we talk about when we talk about AI in the modern world is machine learning, which is a type of AI that basically takes data and runs that data through an algorithm, and that algorithm learns the patterns in the data. And once we've trained that algorithm, that's the step of passing that data in and teaching it those patterns. It can be used on data it has never seen before and give us predictions and forecasts and be actually very, very useful. And that's really what we talk about modern AI is machine learning that learns patterns and we can use it for real world benefit and business value.
Okay, and just to be clear, the patterns, and it's not just like record type data like numbers and text, it's also images and pretty well anything that you can capture digitally.
That's exactly right. So when you think of the types of data we deal with, it is everything from what comes out of a relational database, so highly structured data, to completely unstructured data, text, images. I mean, we're dealing with, I've worked on projects where we looked at spectroscopic images, which are, very, very detailed, massive data sets, like terabytes of data. AI can be used to process those data sets.
Okay. And again, just to for the benefit of the audience, in the IBM context, we've all heard a lot about Watson over the years, and party tricks like winning Jeopardy and whatnot. Are we talking about the same technology? Is it a different name for the same thing? How is what we're talking about with machine learning related to IBM's Watson?
Yeah, Watson is, well, now it's really a brand, but what it originally was when it played that game of Jeopardy and won, it was AI. It is machine learning, but it's type of machine learning for dealing with and handling text. And that domain is called natural language processing. And in that domain, it was very good at searching and finding for things in text and analyzing what a question was and then answering that question. That's evolved into a whole bunch of capability that focuses on definitely natural language processing, but more structured data science and machine learning analytics, as well as even computer vision. So you can leave Watson as our IBM's brand for anything that's related to AI, whether that is natural language processing or images or structured data.
Okay. All right. Well, I guess the audience that's watching today is probably less interested in AI or machine learning in isolation and more interested in practical real-world outcomes. Can you give us an example of the application of AI or machine learning in 2021 in the real world that's getting real outcomes?
Yeah, I mean, you can look at pretty much any enterprise and they're all doing some sort of AI. If you look at the financial institutes we work with on a daily basis, they've implemented AI and machine learning approaches for many years, almost decades in some cases. I've worked on projects where we took modern AI approaches, namely a type of machine learning called deep learning, and applied that to credit card default risk, where we're identifying, could we work out at an earlier stage when somebody might default on their credit card. And just by using modern, state-of-the-art machine learning approaches, we're able to reduce the error that they were getting out of their previous models by about 20%. And in a context of a bank, that can equate to millions of dollars a year in savings and prevent a whole bunch of people from potentially defaulting on their credit cards. So that's one example. I've got many more, and I can talk about some of those if you're interested as well.
I'm sure we'll explore a few more as we go through the conversation. So I guess my impression was that there's a lot of people tippy-toeing around and dipping their toe in the water, to mix my metaphors, with AI. But what you're saying is that it's well and truly embedded into production cycles now.
Yeah, absolutely. I think it's in a lot of enterprises, it's there, and many people don't realize it's been there for a long time. I think over the last 6 or 7 years, we rebranded AI and to what it is today. But really, a lot of what we have done previously, analysis of data, statistical analysis, those things are the precursor to what we're at today, those machine learning approaches. And it's not hard to get into, really. If you've got data and you've got a problem, then you're probably ready for AI.
Yeah. I'll come back to the challenges of getting started in a little while. Just for the context of those watching who've got IBM Power systems, I know that with the IBM Power 10, which was announced earlier this year, that generation allows you to actually embed AI inside same partition as your line of business applications. Adam, what's your insight as to how much of a step forward is that, and what meaningful benefit does that bring to somebody in a production environment?
Yeah, I think first thing you need to understand is basically the two phases of AI. So there's that training phase where you've got data and you're teaching the model the patterns. That requires a lot of compute, and what you're effectively doing is a lot of matrix multiplication. And traditionally, we can do that on lots of CPUs. We've used GPU technology, and we've got power systems with GPUs that can accelerate that workload. But once you've trained the model, then it's ready for production to do real useful outcomes. And that's the inference stage, where it's being applied on data it hasn't seen before. The problem with these inference models is that they still require quite significant amount of compute. And traditional CPUs didn't necessarily accelerate these workloads very well. So in the Power 10 generation, what we've applied is a matrix math multiplier, which is embedded in every core and accelerates the inference of those AI models. So now that when you have data coming into your production database and you want to, say, predict when somebody might churn or identify fraud, that model can run on that same system, and it can be accelerated by those embedded chips, which means you don't have to offload the data, which applies latency, or you've got risks with moving production data out of those production systems. So it can all be done on one system.
So security advantages, integration advantages, performance advantages, time to benefit advantages.
Exactly.
Okay.
And the one great thing is you don't actually have to change anything about the model. You can go train it anywhere as long as it's using the open standard of ONNX, which is an open standard supported by IBM, Microsoft, and a whole bunch of other companies. That open standard means you can just apply it on our system and it will just work.
Okay. David, I might just float a question to yourself based on your perceptions working with clients. And my assumption is that you're working with people who are thinking about it, not too many who have actually taken that step into either POC or production environment. What sort of comments or observations do you get from clients when they're talking about, I'm thinking about it stage? What would you say there? How would you summarise that?
Yeah, quite often we see that people think that first step is quite difficult, as Adam referred to earlier. It's getting started, and it's not this massive massive challenge that people, especially in the Australian market, and a subset of that where we are here in Brisbane, it's not the challenge that people sort of see it is. AI workloads are starting to come into people's production environments sort of almost by stealth, where a lot of the application vendors are starting to build in some capabilities into their systems. We're seeing AI in things like security, where it's predicting denial of service or hacks or crypto, etc. So people are starting on that journey, possibly without even knowing that it's there. But it's really around getting a case, a sample of how could we use AI, and maybe just starting small to prove that journey of what's possible and build from there.
Okay, you just touched on something there that I know. If we go back 5+ years, early days of Watson, AI in general, it was seen, well, starting small was like $500,000. Adam, in 2021, I've heard POCs that can be done for a 20th of that. What's your take on the investment required to do a POC in that machine learning space, whether it's on power systems or on other platforms?
Yeah, I mean, the cost is dropped significantly. We're at the point in some ways where it's almost free. If you've got the data already, you can actually spin up environments on, say, IBM Cloud, for example, that are light plans that don't actually have any cost, and allow you to try a whole bunch of stuff with that data. And there's even capability for auto AI. So we've got products, but another vendor that we work closely with is H2O. They have their driverless AI product that allows you to automate the process of building machine learning models. So you don't necessarily even have to have data scientists on staff to get to AI outcomes and get models. So the cost has dropped to the point where if you're not thinking about it and you have data, then you're missing out, and you might be behind the competition.
So if cost is not the obstacle, what's holding people back in both of your views? Maybe David first. What's holding people back if it's not cost? Is it knowledge? Is it expertise? Is it fear? Too busy?
Yeah, I think certainly what we see is that there is that fear of the unknown, and AI is seen as this super technical. You need to have a whole lot of expertise within your organisation, but it's not necessarily the case. The tools that are available now, as Adam said, they're easy to consume at that smaller scale and build from there. And we can bring in expertise around the tooling and data analysis to assist with the clients, but it's not. We're not implementing a brand new ERP system. We're just complementing what you've got.
Right. And Adam, what do you see as people's perceptions that are holding them back?
Yeah, I agree with David. I think part of it is fear of the unknown, and a lot of organisations, this is a first of a kind, and because they haven't done something before, they don't know what outcomes they should expect. So there's a risk of, do we assign people to work on something that may get us no value? We really don't know. So there's that risk of being first of a kind. But I think one of the other big challenges has been data. Just customers don't always know what they can get out of their data. That they might have a lot of it, but they don't actually know. And so there's this process of really going, well, what's the problem we've got to solve? And do we actually have the data that allows us to solve that problem? So one of the first things we talk about when we go to customers and talk to them about AI is say, well, what's the business problem? And what's the data you need for that business problem? And do you have it? And if they say we don't have it, well, we say straight away, start collecting it, because if you wait for 2 years' time, you're still not going to have the data. And so you're still not going to be able to train the AI model. So it starts today when you start collecting that data. And hopefully you've been doing stuff with it today already and collecting it.
One thing I know that I've heard is people think their data has to have a certain level of hygiene and whatever, as opposed to, well, it's actually more real world if you just use the dirty data that you got. What's your take on that? I may have just coined a new term, dirty data, but what's your take on that?
I like that, dirty data. And any data is better than no data. That's what I'll say. And you don't necessarily always know all the problems you want to solve with your data until you get to the point where you want to solve that problem, and then you've realized you haven't collected any. And so collecting what you can now and not necessarily worrying about whether it's clean or not today is better to just get data. And dirty data can be turned into clean data. You can go through process to clean it up and get it ready and make it viable for machine learning and AI.
So to get a data set ready for machine learning, for the training phase, there is a bit of a process of cleaning it up, I take it?
Yeah, that's right. Let's take an example. An example of a data problem that we see across pretty much every industry that deals with customers is churn. And so I've worked on many churn problems with lots of customers. And what we're trying to do is identify, okay, what's the signal in the data that suggests somebody might leave, so that we can then act on that and prevent them from leaving, whether it's provide them a better deal, lower the cost, or give them some incentive to stay. Now, in that process, we need a couple of things. One, we need data about their behaviors and their actions. So maybe that's the billing behavior. Are they paying their bill on time? How are they engaging on our website? Are they logging into their account? Those sorts of details we can collect. So we've got several systems we're pulling data from there. But the main one is, are we collecting data on people who actually are churning? So do we have and know the data which somebody churned? Do we get a signal about why? Have we followed up? Can we find that information out? Those are the types of things we'll need. So it's the data about what's in the signal. What do we think indicates that somebody might churn? And also the label. That's the thing about what actually happens that we're trying to predict. Do we have whether somebody churned or not? And so if we have those two pieces of information, that's when we can train a machine learning model.
I suppose there's plenty of people around who can analyse this sort of stuff after the churn events happened and go back through the data and say, well, that was an unsuccessful claim, or there was a dispute. What we're talking about is turning that on its head and doing it in a predictive way as opposed to an after the event way.
Exactly.
Okay. Can I just come back to a power systems specific question? Is there anyone watching who's got power systems in their organisation might be sitting there wondering, well, I'm running an application which is written in RPG of some form or COBOL. Those languages or platforms are, have got some history, let's say. And the perception would be that, oh, well, there's no way in the world that I can get my AI investment on power talking to my RPG application and DB2 database. What's your take on that?
Yeah, so we've worked heavily on this. Obviously, Power Systems has a great community of users that have their applications written in code like that. They run on AIX, on IBM I. And so how do we embed AI into those environments? Well, the answer is pretty easily. Again, AI, all it needs is data. So can it access a database with data? The answer to that is yes. Well, then you can use that data to train a model. And we can train the model using Python. And Python runs on top of IBM I and AIX. And so we can run those models in that in those environments, but we could also train them on, say, a Linux LPAR. But additionally, we've partnered with vendors, like I mentioned H2O before. Their driverless AI capability can actually plug into databases on IBM I and AIX. So we can actually pull data straight from those databases and train a model with an enterprise-ready platform that can train that model, and then we can deploy it into production on those same systems. So really the barriers for our existing customer base on power systems are not there. The perceived barriers that people think that because we're running in a different OS or in a more traditional environment, it's not the case. You can get started today with your data.
Okay, so just to put it into, and forgive me if I put words into your mouth, I'm just going to restate this the way I might discuss it with a client. So a typical organisation that's running IBM Power Systems, whether it's I or AIX, have a perception that the skills required are operating system around I or AIX and language, whether it's, as say RPG as an example. What you're saying is that you can wheel in a 22-year-old graduate that knows Python and Linux, and they can be productive in terms of configuring and deploying AI on power systems.
Absolutely, and I've seen it done many times before.
Okay, David, what does that tell you in terms of the opportunity for clients?
Well, one of the things that I've noticed over the years, and it's just becoming greater and greater as the power CPU capacity just continues to grow. IBM are doing excellent jobs in working on performance with Power 10 just coming out as well. Is that it's very rare to see a client that's using all of their system. So especially these traditional customers that are using maybe an older ERP application that may be using a 10th, 1/50th of the machine's capability, and so we've got a lot of CPU compute that's just sitting there idle. It's not being utilised for anything, and so yeah, let's get out there and use it for something else, because those type of applications aren't growing dramatically because they are incredibly efficient in the first place. So an AI workload on those platforms is certainly a very viable option for them. Use what you've already got. The other thing with power technology is certainly in the enterprise space is we've got capacity on demand, so you can have your own cloud on your on-prem machine, where we've got clients that are just turning on CPU by the minute to do specific workloads, either every day at certain times of the day, certain times of the month, or for test runs. So using that sort of capability certainly would tie back into this whole AI journey.
So you could use the on-demand capacity for the training workload, which is very intense, and then when you slip it into production, it's got less impact, and the normal CPU capacity can deal with it. Okay, so
yeah, absolutely.
So David, you're describing a client that might have a machine. They might be on their second or third iteration of power technology. Because of the way the application works, they might be only running at 20 or 30% capacity. So you can stand up a Linux LPAR, you can deploy AI within that, and as Adam said, you're talking about Python skills and Linux, which are generally commoditized skills these days, and get an ROI out of an unused portion of your IBM Power Systems investment.
Yeah, absolutely. The capacity's there. Why not take advantage of it? The default option for people generally is, well, I'll need to buy new servers for this, and it would be an x86 architecture. Well, you've got the capacity. You've already bought the capacity. Why not take advantage of it?
Yeah, fair enough. All righty. And I'm just sort of heading towards the conclusion. Most people have got lots of data rather than big data, just to coin another phrase. What are the sort of characteristics of data sets that you would look for if somebody said, well, have a look around, do a discovery of what I've got, and tell me where I should target my initial AI efforts? Are there any sort of characteristics or profile that you would look for?
Yeah, it's interesting. A lot of people ask this question about what should I look for in the data, and I actually always think that's the wrong perspective to take, because you end up going backwards to try and take the data and solve a business case. Like, well, what business case will my data solve? You're better off going, well, what's the business case I have? Do I have the data? And in many cases, customers will have data that can solve a business case. It's surprising how many times that you go in and talk to a customer and we have this specific problem. I don't know how to solve it. And you say, well, what sort of data do you have? And we collect all these customer records, and well, you've got a signal in there that will allow you to solve this problem. And that's the way I think we should go about it. don't think about data. Think about the problem that today you can't solve with the people you have on hand, and the AI might be able to automate or forecast. And then look for the data.
Yeah. Where does it hurt?
Yeah, exactly.
Yeah. Oh, fair enough.
And the other part to that, Adam, sorry, Colin, the other part to that maybe is there access to data that's outside of the organisation, like social media data that may help with things like your churn example?
Yeah, and the amount of times that the problem that we've seen is related. So a logistics problem. We had a customer that was trying to better prepare their workforce, and they were looking at optimizing who they'd send on truck rolls, and they were looking for data that you might have to help predict your signal. And when we noted down to it, they said the biggest impact was the weather. If it's raining or it's sunny, that totally dictates where we go and how we go there. And we said, well, you've got that data's out there already. Just go and get that data. And so they did, and all of a sudden they had a model that worked really well, and they were 20% more efficient. That was 20% reduction in wages. It was that easy.
But that's interesting. I had David will remember, we had a client that made fresh salads years ago, and their model was that their production manager would wake up at 3 o'clock in the morning and look up in the sky and decide how much salad they were going to make that day, because the hotter the day, the more salad they needed. But that actually articulates one of the benefits. We're taking what's embedded in the data is effectively a supplement, not necessarily a replacement, a supplement or a support to the sort of intuitive knowledge that people who've worked in an area significantly can gather up intuitively and may not even know they know. But from an organisation point of view, it's actually capturing the IP that's embedded in that data in a way that's more distributable and available for the organisation than just being locked up in one person's head.
Yeah, you're scaling the expertise, exactly.
Scaling the expertise, yeah. And I guess that sort of person is very valuable in the training exercise in terms of validating the confidence that you're getting out of the models as you go through the machine learning exercise. Is that right?
Yeah, exactly. Partnering with SMEs is crucial. I did a piece of work where we were working with scientists who are trying to identify healthy versus sick seagrass. This was about trying to protect the shoreline from erosion. As seagrass dies, the shoreline erodes more quickly. And so they needed to analyse how the seagrass health deteriorated over time. And so we worked very closely with the scientists, the marine biologists who actually understood what seagrass looks like when it's sick versus healthy. And that was crucial into making sure that the image recognition model we developed actually could scale that expertise. And so marine biologists didn't have to get in a boat every week and scuba dive, even if they wanted to have a look. We could send drone boats out with cameras that could actually analyze this and identify it at scale.
Okay. Wow, that's another one that I'll just add to my list of applications for this. Gentlemen, I'm conscious of time. I might just head towards the conclusion and ask you for final comments. Adam, first. Any sum up?
My sum up would be that if you've ever been a bit hesitant about AI, or you thought it was the next step you would take in a year or two, I'd say take it today. Go today. Go get online. Look at IBM Cloud for Watson, and get onto the phone to the team here and just understand how you could actually get started, and jump into it today. It's not as hard as you think, and you will get value pretty quickly.
Okay, that's a pretty good recommendation. And David, your thoughts?
Yeah, I think really, it's just starting and finding that sweet spot. We talk about, the low-hanging fruit. Find something that that is tangible within the organisation, something that's definable, but start small and grow. We do see projects where we have a very defined scope of what we want to achieve, and from there just spawns off a whole lot of other potential projects that can turn into projects depending on the business case, just based on as people start to get involved in AI and go, okay, yeah, this is not the beast we thought it was, and being able to expand out on the capability.
Okay. look, I think there's certainly stuff for me to take out of here for conversations with clients and others going forward. So I hope if you're viewing this, that you've got some elements that has added to your knowledge and your understanding of how to apply AI, particularly if you're a power systems user as well. Gentlemen, thank you very much for your time and your insights today. Adam, thank you very much. Much appreciated. And you obviously, you're living in a hotspot in terms of use cases and application of technology. That's very exciting. And David, as are you, May. Thank you for your time as well today.
Thank you.
And to the viewers, our contact details are here and would have been on the invitation that you've seen to register to watch today's episode. Please don't hesitate to reach out to any of us, and we'd love to continue the conversation or expand on the conversation in your particular context, and hopefully help you along the pathway to understanding and validating how you could get more out of AI. Thanks again, gentlemen, and thanks, viewers, for your attention, and keep an eye out for the next episode of One Team IT TV. Thank you. Bye.